So good morning to everyone. I'm Daniel Molina. I'm part of the OpenNebula team. And this is the lightning talk session. As you may know, these are 5-minute short presentations focusing on a key point. And for today, we have 3 talks. The first one will be from Norman, from ePost, talking about OpenNebula and Puppet integration. And after that, we will have 2 talks about Docker. One from the Euro-Mediterranean Center on Climate Change, from Marco, and from Megan, Kishore will talk also about this integration. I want to let you know that tomorrow we have another session at 12, and there are still slots available. So if you want to participate in this session, just talk with me, and we will include your talk tomorrow. Okay, so we are going to do the 3 presentations without questions, and at the end of these talks, we will have time for questions for any of the subjects. Okay, so I let Norman to start. Thank you.
So, my name is Norman Mestorf. I work for Deutsche Post ePost development, and I'm responsible for all on our production side, our live systems. At ePost, we have about 80 developers coding our application by self, and we are running it also by self. And it's very important for us to have a strictly deployment ecosystem. We're using Puppet for configuration management and Hyra for our data in different stages. And everything is shipped over RPM packages. We stage a role YAML repository between our stages. So it is important for us to have a VM management tool to fit into this pattern. And at the moment, we have 2 different tools. We have a so-called Wirtshaus. It's a self-made application in Python using libvirt and managing about 980 VMs at the dev stages. But nobody cares about production. So we had, about a year ago, only libvirt tools plain without any clicking or graphing or anything. And we searched for existing Puppet modules, and no one had support for Hyra. We had to do many stuff by self. So we contacted the author, and he said, "Oh, okay, it's not maintained. It is only supporting OpenNebula 3.6, I think." So we looked around, found some partners. One of them is NETWAYS. With them, we have built a new one supporting Hyra and integrated it into our environment. With our module, you can use regular Puppet types. Like if you can place a file with Puppet with a file resource, you can also create one VNet with Puppet. Or if you want, you can configure your networks via Hyra. We use it in a pattern called software-defined network. So you can describe your infrastructure over a tool. You generate your configuration in Hyra, and this fits very well into our Puppet module. It is nearly complete. You can also configure basics like hook scripts with our module. And of course, you can install OpenNebula on your virtualization host, and also integrate LDAP or configure passenger or start our backup tool. We back up with our module automatically your database if you want, and we have resources for nearly any object you can configure in OpenNebula. Host clusters, VNets, contexts, and VMs. At the moment, we're using plain CLI tools like one template, create anything. This doesn't scale very well. We came into some trouble with the XML RPC API, and we want to switch to this provider. So next things are supporting OpenNebula 4.10. We are still at 4.4, but this will be a lot of, not a lot of work, but we have to do it. And we want to integrate our external systems like firewalls, load balancers, or storage, so we can tell our load balancer if there's a new VM and which IP it has, so it can create a new pool and let it start. Okay, thank you.
Hello, my name is Marco Mancini. I work at the Centro Euro-Mediterraneo sui cambiamenti climatici. CMCC is a non-profit research institution, and it works on climate change research. And I belong to the Scientific Computing and Operations division, that is a transversal division for all the other divisions that do research on climate change, on numerical simulation, and impact on agriculture, soils, and so on. And the objective of the aims of the SCO division is scientific data management. We have high-end computing, and we have operations. We have a supercomputer of 106 teraflops, and that is used for simulation of ocean, of climate, and so on. We are working on a project on cloud computing at the moment, and we are working on providing data analytics a framework for e-science to study climate change and biodiversity. The European project is EU-Brazil CC. And we are using OpenNebula as a private cloud. There are different clouds, and there is a federation of clouds. So we decided to use OpenNebula in our infrastructure, and to deploy Ophidia is the name of the data analytics framework that we have developed at SCO. So why? So this talk is just to like a proposed. We have started to look at Docker recently as a form to virtualization, and to execute, to run the applications on bare metal servers, or on maybe on cloud or local VM and so on. And so just this is what we're looking is to integrate Docker containers into OpenNebula, because our use case could be to use then one flow for quick provisioning and dynamic scaling of data analytics. That's what our use case. We don't work to provide tools for a private infrastructure. We work on research on climate change. That would be one use case if we can try to integrate Docker into OpenNebula. And we are looking at this at Docker because in the containers, and we can exploit the native performance of servers. And since CPU, memory, network, disk I/O is very close to native performance. And so Docker, they say build, ship, and run any app anywhere. So there is a sort of virtualization with containers that can be seen as lightweight virtual machine. Just if you think about Docker component, there is the Docker engine. They use LXC, and they have some other components that are needed in order to deploy, to build, and to run the application. One is Docker image is the basis for the container. Then they use the Docker file. It's a recipe to build, for example, a container. So you start from an image, you have several commands, then you run your app. Then they use a registry to share story image. Registry could be a public, like the Docker Hub. And then you can also implement a Docker registry in a private infrastructure. And another concept is the data volume, how to persist and share data between containers. So we started to look at this, and just we have thought about how we can integrate and use Docker with OpenNebula. We are still at an alpha stage, I mean, just to how to integrate with OpenNebula. So for example, for the images, the data store could be the Docker registry, a private or a public Docker registry. Just we can use Docker pull and push to transfer images on the host. Regarding data volumes, at the moment, our deploy for the project that we are working in, we are using Ceph as a storage, para-distributed storage. And what I say, for example, for the other managers, like the information manager, we can use Docker Inspect to see the state of the container and to have information about the container. For managing the VM or the container, let's say, we can use Docker Run to deploy Docker Stop RM, and if you want to migrate a container, if it's with the state is stateful, you need to import export. If there is no state and they use some persistent storage, then you can run from the image because you don't need to save the data, because container has ephemeral data. They will die when the container will stop. And now at the moment, Docker doesn't support Ceph or remote volume management. I reported below some open issue on GitHub on Docker that they are proposal to integrate. But how it works in importing volume is you need some directory on the host where you deploy the container. So usually when you deal with the persistent on the shared storage, you need a directory on the host, and then this directory is bind mounted on the container. So one way we can use with Ceph is to create and with the RBD we can map to a device, then we can mount as a directory on the host where the container will deploy, and then we can bind mount by running Docker run -v with the directory that we have created. It's a bit there are some operations to do, but I think that maybe Ceph will be in we will be supported maybe later. There are some issue open, and so to deploy the container we can use then Docker run. As a template to use for containers, usually you need the name of the image, image tag, and the volume, eventually for persistent storage. And then the difference with the virtual machine, usually you expose ports. You don't use networking. At the moment, networking is a big issue for Docker. Indeed, if we deploy a container on an host, in order to access, we need to expose the IP of the host. And there are some solution like Flannel that is run on CoreOS that use a sort of overlay network as use Google for Kubernetes. And that one could be one solution, but there are several also proposals for networking. Just if you think about security, the problem is the container can run as root, and so you cannot use all the features of Docker, because otherwise it would be a security problem for your host. And something to think about, if we want to use one flow of OpenNebula, should be linking containers. How can I can link one container to another and give this information by OpenNebula, and to share also volumes between containers. That's all. Thank you.
Okay. Hi, I'm Kishore. I'm the CTO of Megam Systems. I'm from India. We use OpenNebula as our infrastructure as service for the private cloud, and we have built cloud automation, cloud platform on top of it. This video is going to demonstrate how Docker can be used in OpenNebula and other hybrid clouds. We followed a different approach rather than going by the native host model, but host is also something interesting to us. So in this video, you will see that how a virtual machine gets spinned off CentOS 7.0 that has got bundled with systemd, and the OpenShift Geary Cloud Orchestrator, and how you can also use Megam to run containers in this virtual machine. So,
hello, welcome to the first part on Visual Docker. In this tutorial, we will cover how you will launch a Dockerized VM, how do you launch multiple containers, and how do you actually test it. We also provide a seamless way of networking your Docker containers, all in a single click in Megam. Launch Megam and click on the marketplace. You will see an add-on called Docker. Click on Docker. It opens up an add-on dialog. On the dialog, pick the cloud that you want to launch your Dockerized VM. Okay, let's launch the Dockerized VM in the cloud of choice. Press create. Give us a couple of minutes. You will see that your launch will appear on the main dashboard with the name, with the application name that you just provided before. So if you see, there are no running containers so far. So let's see what our Dockerized VM is doing. Start by SSHing into your account using your private key. Type the command docker ps. You can see that there are no containers that are running. And you also see that you have Docker install and other tools built into your VM. Okay, we need to stick more containers into your VM. So you can see that there is a setting that gets built into Megam by the name HP Cloud Docker. We are going to visually compose containers into our Dockerized VM. Go ahead and click Visual Designer. Our Visual Designer opens up. Drag and drop the cloud setting. Select the cloud of your choice. Pick the cloud of your choice, which is HP Cloud Docker. Drag and drop a runtime Java. Provide a Docker containers URL from the Docker Hub registry. In this case, we are going to use a Java container which runs Tomcat and a drawing application. Click deploy. Upon deployment, when you go to the URL, you can see that there is a drawing app that just comes up. Let's launch another Docker Hub Node.js blogging platform called Ghost. Again, drag and drop a cloud setting with pick a cloud called HP Docker and then the runtime Node.js. Provide a container Docker Hub registry for Ghost and then deploy it. It's time to test both the applications that were launched in the Dockerized VM. Both the applications are web-based applications. The first application is a drawing application. So there you go, you can see a drawing app. The second application is a blogging platform based on Ghost. You can SSH into the Dockerized VM and then do a docker ps. This will actually list 2 containers that are running inside our VM. So this basically validates the 2 containers that were shown on our Megam dashboard. What you saw before were basically standard containers that were run in a Docker VM. But you may have your own Java code that you want to build it as a var and deploy it in Megam. Sure, you can do. So if you want to do that, you got to build a Docker file like shown as we have shown here. Keep watching our series. We also plan to provide the next series with more logging of containers, how you can stream it in Megam, and also meter and monitor them. Thank you.
okay, thanks a lot. Yeah.